In experimental measurements, you cannot avoid error. The key is to account for the errors, reduce them, and estimate how big they are. In this example, I'm trying to measure how long it takes for something to drop half a meter. I'm starting a stop clock as I let go and stopping it as it hits the bench. Sometimes I probably start the clock too early, and sometimes stop it too early, sometimes too late. From the wide range of times, you can see that this is highly inaccurate. This random variation is due to human error. In science experiments, some random error is often unavoidable, particularly if there is a human taking the measurements. One simple way of reducing the effect of the error is to take a number of measurements and then find an average. In addition to that, we can look for a trend. A standard, simple experiment to measure the properties of a material by extending a spring. Measure the spring at the beginning and put a small weight on it, measure it again to find the extension, and repeat this with ever increasing weights. We tabulate this with the force, and then the first length measurement, and then a second length measurement. From the average measurement of the original length, we calculate an extension at each unit of force. We plot a graph that shows a clear trend, linear in this case, and the graph line tends to average out the errors. An error is systematic if we do exactly the same thing each time. Here I've lined up a ruler with the edge of a piece of paper to measure its length, and I'm looking along the ruler to the other end to get the length, and it looks like about 295 millimeters, I think. However, if I move my head along and look at it straight on, then it's not 295. If I look at it properly, it's 297. I've made a parallax error. And if I measured the paper the same way every time, I'd make exactly the same error every time. Another example, measuring out some chemical. Put a bowl on the scale and measure some out. I've got 62 grams. Well, not really, because if I empty that out, I have forgotten to take into account the mass of the bowl. And, in fact, if I take the bowl off, I've also not taken into account that the balance did not start at zero. These are avoidable systematic errors. Errors that make the same mistake every time in the same direction. They can be corrected, and by careful experimental design, you can avoid them. They are something to think about before you start an experiment, not when you've finished. Thank you for watching.